In lesson 2.6, we're looking at making and analyzing stem and leaf plots. So our first question we need to probably ask is, well, what's a stem and leaf plot? Well, it's a graph that shows digits of each number, or uses the digits of each number to show the shape of the data. So if I were to give an example of what that may be, we first need to say, well, our numbers are broken into two parts, a stem and a leaf. So let's use the number 58 as an example. Well, if I took 58 and I broke it into a stem and a leaf, well, I'm going to take a line and break it straight down and say, well, the 5 is my stem and my 8 is my leaf. The 5 with the bar down the middle between the 8, that would equal 58. So if I then were to say I had 12 with the bar and said 3, so 12, the slash, and then 3, this number would equal 123. It's always important to look at what the key shows, because we could also say that we have a stem and leaf plot with a key that may say, 1, a bar, and let's say a 7, and that equals 1.7, 1 and 7 tenths. So there's a big difference between 17, if we follow the other key example, and the key here saying 1, the bar, and 7, meaning 1.7. So it's always important to look at what the key shows. So let's look at an example. Time customers waited for haircuts is shown below. So we look at our question saying, well, how many customers waited more than 10 minutes? So we need to look at our key, and it says 0 and the slash and 5 means 5 minutes. So if I look at all the zeros, they go up to 9, and then I can look here and say, well, 1, the slash, and that 0 is 10. Well, how many waited more than 10? So I need to look at this and say, well, 1 and then this 1 means 11. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 customers who waited more than 10 minutes. And then their times that they waited, well, I've got 11 minutes, and then I could look at that and continue saying, well, 13, 14, 14, and then I have 19, and then I have 21, 22, 24, 26, 30, and 32. The longest wait time would be the greatest one here, and the 3 on the left side of our bar in our stem and leaf plot is a tens place, and then the 2 is in the ones, so 32 minutes. So then we look at our follow-up question, what's the range of the data? And we say, well, 32 is our greatest, and range is always taking the maximum minus the minimum, and that will always equal the range. So if I had my maximum as 32 and my minimum was 1, so then my range would be 31 minutes. Let's take a look at another one where we have to now construct one. So here's a stem and leaf plot showing bowling scores. So our step 1 is to write the stems in order. And if I look at my stems here, I have, well, these are 3-digit numbers. And so I guess the best way to do this would be to say, well, I'm going to break it up and say I've got my tens place being everything greater than the tens place, so tens and hundreds would be to the left of the bar, and then our ones place would be to the right of it. So let's say that let's use this 90 as my example for my key. So 9, and then the bar here, there's a little line right between the boxes, and then the 0, that is going to mean 90. So write my stems in order, and I'm going to start with my least at the greatest, so I've got 9, and if I look at all my numbers here, well, I see I have, 100, so I'm going to write a 10. And I have to write these in numeric order. Even though they may not show up here, I still need to write, for this one, 11. there is no box, so if I did, that would be everything, 110 through 119. I don't have any up there, so that's why there are no boxes, and I would leave that blank if I were making it without boxes. So then I continue on and say 12, 13, and 14. So then I'm going to draw a vertical line to the right of the stem, showing that I have, so I can identify what my stem is and what my leaves are. It may also help to write these in numeric order. And to write them in numeric order, so then I may say, write my leaves in order. So I look through and let's say that I'm going to write these in numeric order to make sure I use them all. So I've got 90, and I'm going through, I see I have a 93, and I have a 97. I've got 100. I have a 105, 108, and there's another 108. I do not have anything in the 110 spot, so I don't even want to write that. Don't even get in the habit of writing 110 there, because then you'll look for it to put it in your stem and leaf plot. So my next number I do have is 123. And then I have 124 and 128. There's a couple 130s, and then a couple 133s. And then my last numbers in my stem and leaf plot, this row down here, my 14, or the 140s, is 141. 142, 146, and 148. So now that I've written them in numeric order, now I can just look at this and say, well, I have 90, 93, and 97. There's 100, 105, 108, and 108. There is nothing in the 110 through 119, so that's why there's a blank there. And then I have 123, 124, 128. There's a couple 130s and a couple 133s. And then I have 141, 142, 146, and 148. And then last, I need to make sure I have a title, because it is a graph right here. So I need to say, well, what is all this information? Well, they're bowling scores. Then I'm done. Always make sure you have a key so that we understand what this information means, because as we showed before, this 9 and the slash and the 0, we don't want to confuse it, meaning that it could be 9.0 or we add in any other variation. Now we need to construct another one. However, this one does not even have boxes, so we need to be careful that we order our data correctly. It does give us some information. Here we need to add in. So the information, the data shows the number of students who voted for class president each year. Make a stem and leaf plot. Well, let's write these in numeric order. And I'm going to use the ones digit for my leaves. So again, I'm splitting this up right down from my tens and my ones place. That helps to identify what these mean. Go ahead and mark that first. Otherwise, just be very careful that you do not mix them up by putting it with your the bar in between your hundreds and tens place. So let's look at our least value for our stem, and I've got 13, 12, 14, 18, 13, 14, and 12 is my least. So 12 is going to be the least up here. Let's use that as our key. And let's say this 125. So I have 12, this bar right here, and then 5. Well, that means 125. So let's write our numbers in numeric order so that we make sure that we put them in numeric order down here as well. So if I go through, what's my least? I see 125, 123, and if I keep on going through, 124, oh, there's a 121. So let's start there. So I have 121, there's a 123, 124, there's a couple 125s, 126, and 127. Fix that 5. Following by, I see there's a 130, 132, 133, 136, 137, a couple 138s. There's a 140, 141, 144, 145, 150, 155, and then if I keep on looking through, I don't see any 160s, I don't see any 170s, but I do see a 181. So, again, I'm going to write these with my stems. I have to go in numeric order, put the least one at the top, so I've got 12, 13, 14, 15, 16, 17, 18. And so then I'm going to write my leaves from here. So I've got 121, 123, 124, 125, 125, 126, and 127. I have 130, 132, 133, 136, 137, 138, another 138. There's a 140, 141, 144, 145. There's a 150, 155. There was no 160s or 180 or 170s, but there was a 181. So our stem and leaf plot is almost done. I need to add one more bit of information, and that is, what is this information talking about? Well, it's the number of students who voted for class president. So we could say our title, class president, make sure to cross our T, and we say class president votes. And we could even say each year. That is the end of our lesson over stem and leaf plots. Hopefully this helps.